All right, class, so this is where we needed to pick up, just a continuation of the endocrine system. We already spoke about several of these, which are also, of course, a part of the endocrine system, but it's just labeled how it looks and where it's located throughout the body. One thing that I do not remember mentioning to you all is that the gonads are the hormones that regulate the sexual characteristics and reproduction process. And either that's the ovaries in females or the testes in males. So just wanted to make a note about the gonads. You can also find gonads on page 55 in your textbook. Be familiar with that. All right, human brain. I may pull from this particular area for a possible bonus, but I want you to be familiar with how much the human brain weighs. As you can see, roughly 2% of the body's weight. Also, the human brain uses about 20% of the body's energy. So just kind of make a note of those two things as it relates to the human brain as a possible bonus. All right, as we continue, we're talking about brain damage risk. Really the area that I'm going to focus on, or want you all to focus on, is going to be plasticity, and also the kind of tools of the trade as it relates to brain and detecting any type of brain injury or damage. So before I move forward to plasticity, just listen and just make a note of these tools of discovery as it relates to brain damage or brain trauma. So you can find these tools on page 56 and continuing on page 57 in your textbook. The first term I want you to be familiar with is going to be PET, which is positron emission tomography. You've probably heard of it titled as a PET scan. And so this is a tool that is used to provide a image. It's color-coded of the brain activity. And so basically the brain is going to be, or you'll be told as a person, to perform a given task by whoever is administrating the PET scan. And they'll inject the glucose into you so that those particular areas will light up based on the task that you're given. And the areas that I'm talking about is the areas in the brain. So the glucose, what it does is highlight those areas so that they kind of light up like a Christmas tree in your brain when you're told to perform whatever task, okay? And so that's how the PET scan works. The next tool of discovery is called the magnetic resonance imaging, which we've heard it typically referred to as an MRI. An MRI is going to be used in situations where a person may have got into a accident. It can also detect dementia, seizures, MS, okay? And so this technique is when an image is produced, and it just shows the tissues where it is generating any type of magnetic fields. It can also show if a person has had strokes as well. So any type of damage to the brain, okay? The next term is going to be, let's see, they should have had EEG listed in here as well, but I don't see that they do. So just for the purposes of what's provided and what's listed in your textbook, let's just focus on the PET scan and the MRI. All right, so we'll move forward. Let's go to plasticity, and we're going to focus on functional plasticity. Really simple and plain. What plasticity is the brain's ability to shift functions from an undamaged area to a damaged area, okay? And so it's the brain really trying to repair itself is what plasticity is, but it's trying to repair itself after some type of damage or trauma that has occurred. So if a person has had a head injury, then the brain will attempt to conduct plasticity. This may not happen in all cases, especially if it is too severe. Plasticity also consists of the brain attempting to regenerate new areas, kind of new functioning areas of the brain. So to some degree, like trying to attempt to produce new brain cells. That happens at a very, I would say, minimal level, because I don't want you all going out thinking that, hey, if a person has a head trauma or a head injury, all that has to happen is plasticity, because the brain will fix itself. It attempts to, okay, but it is never at 100%, okay? So that's what occurs. So if a person, if plasticity is able to occur, and yet the person had the part of their brain traumatized or injured that is responsible for memory, they may recover some of their memory, but still experience some memory loss, where it's not total gone, but yet it's able to function, but not to 100%. So be familiar with functional plasticity. You can find that on page 58 in your textbook. And I have a really interesting story when we talk about plasticity, about Phineas Gage. And you can find that on page 63 in your textbook, 62 and 63, but really 63. And it's an amazing story of how Phineas Gage had brain damage because of a traumatic event, and the ability for the brain to repair itself to a certain degree so that he could continue to function. And even in the textbook, he's taking a picture holding the pipe that actually went through his eye, and really went through his whole head, but it started in his eye and went through his brain, part of his brain as well. Okay, so interesting story. Please make sure you read it because it really drives in how plasticity works. All right, so I want you to be familiar with the major sections of the brain. First up, the brainstem, which consists of the hindbrain and midbrain, and then the forebrain. And then let's break down the hindbrain. So the hindbrain consists of, and it connects the spinal cord to the rest of the brain. So hind in the back, okay, if that helps you kind of understand its location. And the hindbrain consists of the medulla and cerebellum. Those are the areas that I want you all to focus on. So the medulla is located, and we'll see a whole diagram of that on the next slide, but the medulla is at the base of the brain, and it's responsible for controlling breathing, breathing and heartbeat, and also circulation. The cerebellum, also of course located at the back of the brain, and it is responsible for muscle coordination and maintaining posture and equilibrium. So when you look at the area where the cerebellum is located, which is directly like right there behind your ear, if you have ever experienced vertigo, it's because it's an inner ear issue, and the inner ear and the cerebellum are right there by each other. So this is why a person feels off balance and sometimes they can't even stand up straight, because that particular area is affected. So it's affecting your posture, your ability to just walk in a straight line, your ability to feel like things aren't shifting or moving when you are standing still. Also, this area is affected greatly when a person has been drinking alcohol. So a person will think that they are walking in a straight line, but they're actually not. The cerebellum has been flooded with that alcohol, so it affects our muscle coordination and maintaining our posture, all right, and balance. So let's move on here so we can see it. So here it really gives you a really good breakdown as far as location and what the areas are responsible for. So we just talked about the cerebellum for balance, posture, movement, equilibrium. medulla, breathing, heartbeat, and other vital life functionings, also such as swallowing. So please, please, please be familiar with that as well. Forebrain, uppermost and largest brain region. This particular area is responsible for judgment, decision making, part of our personality. So I want you all to start considering, man, if I had damage to this area, how that would affect me as a person. If I had damage to that particular area, if it's significant enough, you're going to die in that particular area. And then we have the midbrain. Okay, we talked about the forebrain, we talked about the hindbrain, what it consists of, and then let's talk about the midbrain. Okay, the midbrain is involved in our vision and our hearing. Okay, and so that's its responsibility. So trauma to that particular area could cause a loss of vision, loss of hearing. Okay, also responsible for, we talked about vision and hearing, but with sound localization. So sound localization is our ability to detect where the sound is coming from. So if we heard something really loud and it was on the left side, we know to look to the left. So that's really what sound localization is. It's our ability to locate where sound is coming from. And also eye movements is a part of the, not functioning, but responsible area for our eye movement, which is a part of the visual information processing. Okay. Here, with the just kind of giving you all some more information, because I didn't dive as deep as I should have into the forebrain, but to just give you some context with the cerebral cortex, gives you some vague information, but to be more specific with the cerebral cortex, if you have damage in that particular area, which is a part of the front part of your brain, that would be a language disorder, and your mobile ability to speak or understand spoken or written language. Okay, so if you have damage there, you could become mute. You could become where you would have broken up speech. You can just talk freely, or the flip side to that, you can talk freely, and yet it'll be word salad, where because you can't process what you read, you can't process correctly even your own understanding. So if someone asks you a question, you may respond with, they may say, hey, how's your day going today? And you may say something such as, green grass day all the time, good, thank you very much, good night. It makes no sense because it's your processing because of damage to that particular area. So, just kind of make that note about the cerebral cortex. And let's go into the four lobes. The four lobes is going to be picked up actually in the next part of the audio lecture. So you'll see it there with the, and we talked about the cerebral cortex. I just kind of told you everything that it did, and it's going to break down the four lobes, which is listed right here in the next audio lecture. So make sure that you kind of hone in on that to, kind of make the necessary notes that you need for Chapter 2 exam. But here's Phineas Gage, who I was talking to you all about. It's showing you a structure of actually what happened when it went through. So it kind of popped his eye out. So very interesting story. He lived through it. You can see that pole there. So just make sure that you take the time out to read that story, learn about kind of how important each area of our brain is and what it's responsible for, and how it's ever changed if we are to experience any type of brain damage or trauma. And then also how plasticity works for him to even have the ability to still be able to take a picture and be holding the pole that actually changed his life. All right, so make sure you pick up on the second half of the remainder of Chapter 2.